Hi students, welcome back to our channel. This is SSC and this is the part 2 session for coordinate geometry. If anyone didn't watch the part 1 session, I will provide the link in the description. Go and watch it, or else in the cards you can available. It is available. Now in this part 2 session, we are going to discuss about the section formula, which means a point which is dividing a line segment in the ratio m is to n. So we will derive the formula for to find the coordinates of a point which is dividing a line segment in the ratio m is to n. Suppose a line segment joining two points, suppose those 2 points we take it as a and b, and this line segment is divided with a point, is divided into two parts by a point called P. To find the coordinates, that is the x comma y values of the point P, we are going to use this section formula. This point is dividing this line segment in some ratio m is to n. M is to n. So this is m. This is right. So the denotation will be like AP is to PB. AP is to PB, where point is dividing internally. The division is also occurs in two ways. One is the point may divide the line segment internally, or the point may divide the line segment externally. If you observe here, the 2 points A and B, this is the line segment. On extension of this line segment, somewhere else the point P may divide this line segment externally, then the ratio will be AB is to BB. This may be M, this may be M. So here it is dividing externally. Externally. Here it is dividing internally. So these are the two ways where the point can divide the line segment joining 2 points internally or externally. So for our SSC, we are having internally division. So we will see for the formula for the coordinate, how to find the coordinates of this point when it is dividing a line segment joining 2 points internally. Okay. Now consider the coordinate system. Consider the coordinate system. Consider the coordinate system. You take here little bit left. Now consider a line segment, 2 points joining 2 points A and B. A and B. Take the point A as x1 comma y1 and point B as x2 comma y2. Now this line segment is divided with a point P. A point P. Let us assume the coordinates as some x comma y. Actually, we are finding the coordinates x comma y. As we don't know the coordinates, we are assuming it as some x comma y. And assume that the point is dividing this line segment in the ratio m is to n. So the ratio A to P will be m and P to B will be n. As the point is in between A and B, so we can say it is dividing AB in the ratio m is to n internally. Now we need to derive a formula, section formula, to calculate the coordinates of the point P. Now project these points on x-axis as well as on y-axis. Project these points on x-axis as well as on y-axis. So when you project these points, it shows the distances of the point from x-axis and y-axis. So the distance here it is x1 and here the distance is y1. As well as the point distance from y-axis is x and the point distance from x-axis is y. Similarly, point B, the distance of this point B from y-axis is x2 and the same point B distance from x-axis is y2. Now if you clearly observe the gap between point A and B on projections on the x-axis, this gap can be find out, as we know the total distance is x and a part of it is x1. The remaining distance will be x minus x1. Now this is x minus x1. In the same way, the projections of point P and B, the distance between these two will be calculated. As we know the total distance here it is x2 and the part of it is x. The remaining distance will be x2 minus x. In the same way, the projection on the y-axis, the gap between A and P is y minus y1, as well as the gap between P and B is y2 minus y. Now construct a parallel lines to the x-axis which is passing through point A as well as point P. Now we can observe here, as we are taking the projections, it will be always perpendicular. Now we are having two right angle triangles here. One is PA. Let us take this point of intersection as some n, and here the point of intersection as some n. Now if you are clearly observe, there are two right angle triangles, right? Here angle n is equal to 90 as well as angle m is equal to 90, and as we have taken parallel lines to x-axis, we can say these two lines are parallel, and PA will become the transversal, where this angle A as well as angle B will be equal because these two are corresponding angles. Now take these two triangles separately. Take the two triangles separately. We'll get APN as well as another triangle PBM. Now from the triangles you can clearly observe that angle N is equal to angle M, since both are 90 degrees, as well as angle A and angle P are equal because they are corresponding angles. Now if in two angles are equal, we can say these two triangles are similar triangles. Here angle A is equal to angle P, since they are corresponding angles. As well as angle N is equal to angle M is equal to 90 degrees. So by angle property, by A similarity, we can say this triangle A P N is similar to triangle P B M. So we got that these two triangles are now similar. From similarity concept, we are having, if two triangles are similar, then their corresponding sides are in proportion. corresponding sides are in proportion. Now you'll see, as we got till here, two triangles are similar. You'll see the corresponding sides are in proportion. So what are the corresponding sides we are having? AP and PB. So we'll take AP by PB. AP by PB is equal to, next, AN by PM, which is equal to PN by PM by PM. Now substitute the values. What is AP? As we have considered the ratio as m is to n, so the AP value is m here. PB value is n. Now AM is the distance between A and P, the gap between A and P, that is x minus x1 by PM distance is x2 minus x. Now in the same way, PN is y minus y1 and PM is y2 minus 1. We got the ratios. We got all three ratios. Now what all three ratios are equal? So we need to find the coordinates of the point P, that is x comma y. So first equate the x coordinates to the ratio m is to n. X coordinates are to the m is to n. Now m by n is equal to x minus x1 by x2 minus x1. Across multiply, you will get m into x2 minus x is equal to n into x minus x1. Now upon multiplication, we get mx2 minus mx is equal to nx minus nx1. Now simplify for the value of x, so bring all x terms to one side and the remaining terms to the other side. So when you do that, you will get mx plus nx is equal to mx2 plus nx1. Now take x as common here, you will get m plus n. Here mx2 plus nx1, right? Now find x value. X is equal to mx2 plus nx1 by m plus n. So when you solve for x value, you are getting x is equal to mx2 plus nx1 by m plus n. In the same way, when you equate y coordinates to the ratio m is to n, you are going to get y is equal to m by 2 plus n by 1 by m plus n. This is how we are going to derive the section formula, which is nothing but to finding the coordinates of a point P, which is dividing a line segment joining 2 points in some ratio m is to n. Now the point P coordinates will be these two, x comma y, which are mx2 plus nx1 by m plus n, and y is m by 2 plus n y1 by m plus n. Now see the different cases. So the point P coordinates I am writing here x comma y, which is mx2 plus nx1 by m plus n and my2 plus my1 by m plus n. So this is the point which is dividing a line segment joining 2 points in some ratio m is to n. So now we will see different cases based on the ratio. Now what happens if m is to n is equal to 1 is to 1. See what happens if the ratio is equal, 1 is to 1. Ratio is equal. So we can simply say when the ratio is equal, the point P will be exactly lying in between A and B. That is, it is called as a midpoint. It is called as a midpoint. So we will check how to find the midpoint of a line segment joining 2 points A and B. Now the point P coordinates will become, when m is to n is 1 is to 1, simply replace m value as 1, n value as 1. Now you will get x2 plus x1 by 1 plus 1 is 2. Similarly, you get y2 plus y1 by 2. So on rearranging the terms, you will get x1 plus x2 by 2, y1 plus y2 by 2. This is the point P x comma y, which is called the midpoint of a line segment joining AB when the ratio is equal to 1 is to 1. This is called the midpoint. This is called the midpoint. Now we'll see a line segment when it is divided into 3 parts. Now a line segment is taken AB. This line segment is divided into 3 equal parts. 3 equal parts. So when we are dividing a line segment into 3 equal parts, we require 2 points. 2 points to divide a line segment. To divide a line segment, we require 2 points. So we require 2 points to divide into 3 equal parts. Now this all 3 are equal parts. All 3 are equal parts. So when you take all 3 are equal parts, that means AP is equal to PQ is equal to QB. So when you find the ratio between these distances, you will get 1 is to 1 is to 1. 1 is to 1 is to 1. Now if you want to find the coordinates of the point P, which is dividing this line segment AB, in which ratio, you can simply say that this is one part, this is one part, this is one part. Now as we are finding the coordinates of point P, we have to measure the distance up to P. So that is AP is to PB, which is 1 is to 1 is to 2. 1 is to 2. Now if you want to find the coordinates of point Q, now this point Q is dividing a line segment joining AB in the ratio AQ is to QB. AQ is to QB. Now AQ is 2 units here, QB is 1 unit. So the ratio in which line segment AB is divided by the point Q is 2 is to 1. 2 is to 1. The points which are dividing the line segment joining AB in the ratio 1 is to 2 or 2 is to 1, those points are called points of trisection. They are called trisection points or points of trisection. Now we will discuss how the points of trisection will be by using section formula. Let us take this point as x1 comma y1 and point B as x2 comma y2. Now this line segment is divided into 3 equal parts. So we require 2 points P and Q. Now we know that point P will divide AB in the ratio 1 is to 2. 1 is to 2. To find the coordinates of this point P, we use the section formula, right? So Px comma y will be, now we already know that m is to n is 1 is to 2. So apply that in the section formula. We already know that section formula is mx2 plus mx1 by m plus n, my2 plus ny1 by m plus n. As these are the coordinates of some point, make sure that everyone, when you are writing, use the open brackets. Use open brackets. And this is equal to some point px comma y. Now substitute the m and n values and x1 x2 values over there. You will get m x2, m is 1, so x2 plus 2x1 by m plus n m plus n, which is 1 plus 2, which is equal to 3, as well as y2 plus 2y1 by 3. Now let us find the coordinates of point Q, which is dividing a line segment in the ratio 2:1. The point coordinates Q, x, comma, y will be the same formula, but ratio m is to n is 2:1. So 2x2 plus x1 by 2 plus 1 is 3, comma 2y2 plus y1 by 3. Now these are the points of trisection. Which are dividing line segment joining A and B in the ratio 1:2 or 2:1. You can remember these formulas, or else you can take the ratio and simply substitute in the section formula. Now we will see the centroid formula derivation. Next one is a centroid formula derivation, where we will use this section formula. Centroid, when 3 vertices are given. We already know that centroid means it is the point of intersection of medians. If I take ABC is a triangle, the point of intersection of medians is called centroid. So if I take two medians from vertex A and vertex B, they intersect at one point. That point is called centroid. Centroid is denoted with G. Now what is median? A median is a line drawn from vertex of a triangle to its opposite base midpoint. That line is called as a median. So line drawn from the vertex of a triangle to its opposite side midpoint, it is called a median. So the point of intersections of medians is called a centroid. As we know that it is meeting at the midpoint of the opposite side. So if you take these coordinates as x1 comma y1 and point B as x2 comma y2 and point C as x3 comma y3. We know that this point, let us take this as D. Then this D is the midpoint of BC. So we already learned that the midpoint formula, that it is average of the x coordinates as well as average of the y coordinate. So this point will become x2 plus x3. This point will become the coordinates x2 plus x3 by 2, comma y2 plus y3 by 2. This is the coordinate of this point D. Now we already know that this centroid will divide the median in the ratio 2:1. So using this ratio 2:1, we will find the coordinates of the centroid G. So G coordinates will be, it is dividing this vertex A and D, A and this line segment A and D in the ratio 2:1. Now apply the same formula, mx2 plus nx1 by m plus n. Here x2 is this, so 2 into x2 plus x3 by 2 plus the ratio is 1, n is 1, so 1 into x1 is x1 by 2 plus 1 is 3. 2 plus 1 is 3. In the same way, 2 into y2 plus y3 by 2 plus y1 by 3. As 2 and 2 will be cancelled in both ways. When you rearrange the terms in order, you will get x1 plus x2 plus x3 by 3 as well as y1 plus y2 plus y3 by 3. So simply you can say that the centroid of a triangle, when three vertices are given, you can find by taking average of the x coordinates of the given vertices as well as the average of the y coordinates of the given vertices. That is the centroid of a triangle. Centroid of a triangle. Now this is our part 2 session, and in the part 3 session we are going to learn about deriving the area of the triangle formula and slope of a line which is passing through given 2 points. So this is the end of our part 2 session. In the part 3 session we will discuss about area of the triangle, how we are going to find, and as well as the slope of a line which is passing through 2 points. Hope everyone understood this concept. Thank you so much, and please subscribe our channel, like this video and share this video so that everyone can understand this topic.